All right, in the last video, we had something pretty interesting over here. Notice all of these sines and cosine values, almost all of them, I don't know what that is, almost all of them were decimal approximations, but some of them had really nice answers. And that's going to have to do with our special triangles that we are going to introduce right now. Okay, so we're going to have two special triangles. The first one is a 30, 60, 90 triangle with side length pi over 3, which is 60 degrees, pi over 6, which is 30 degrees. So again, as a side note, this right here is 60 degrees. This right here is 30 degrees if you are a little uncomfortable on your radians for now. And then this has this very special relationship. So the short side is going to be S, and the hypotenuse is always double whatever S is. And we saw exactly that over here. We said sine of 30 degrees was 1/2. The ratio for the opposite and the hypotenuse for that angle is 1/2. The ratio for 30 degrees between the opposite and the hypotenuse is 1/2. Because S over 2S, it doesn't matter what S over 2S is always 1/2. So we saw that special triangle kind of pop up in a previous video. And then the longer side, the one opposite 60 degrees or pi over 3, it's not quite as nice, but it's still a little nice. It's the square root of 3 times S. Unfortunately, square root of 3 is a bit of a bummer. It's a bit irrational, but we can write it like this. That's one of our special triangles. The other special triangle is a 45, 45, 90 triangle with angles of pi over 4. It's an isosceles triangle, right? These angles are the same. So these sides have to always be the same. And whatever side length that is, the hypotenuse will be the square root of 2 times that side length. And again, if you want, you can think about this as 45 degrees instead of pi over 4 radians. It's kind of a little bendy triangle right there. Not quite so straight. That's okay. So these are our two special triangles, and they allow us a lot of power to do things by hand. But we're going to be using computers for a lot of this class. But if you wanted to say, to heck with this computer, you could do it for these triangles. All right, let's do an example. Example 4. Example 4 says, use the above triangles to, ready for this? To calculate without, W-O, without a calculator. Wait, calculator have an E? I don't know how to spell calculator anymore. Calculate, I know calculate has an E. All right, who knows? It doesn't matter. Maybe it's an O. All right, calculate without a calculator. I don't know, that looks weird. Here we go. Part A. Sine of pi over 6. Remember, all this is asking, every trig function says we're looking at the ratio of two sides. So first, what are we going to do? We're going to locate pi over 6. All right, I've located it. And then sine, SOHCAHTOA, S-O-H, is opposite over hypotenuse. So locate the angle. Locate the opposite side divided by the hypotenuse. That's going to be S divided by 2S. Ah, cancellation. and it cancels to 1. We're left with 1 divided by 2. That's the sine. That is one way that we can use these triangles. Let's do another one. And this should be the same answer. Pi over 6 is the same as 30 degrees. Should be the same answer as the previous video. Let's do cosecant. Pi over 6. Ooh, cosecant. What the heck was cosecant? I don't remember. I'm lying to you guys. I do remember. Cosecant is the reciprocal of sine. Cosecant is 1 over sine. So there's two ways of doing this. You could say, okay, sine is opposite over hypotenuse. So cosecant is hypotenuse divided by opposite. But why do more work when you can do less work? Am I right? We already found sine of pi over 6. So cosecant is just the reciprocal of our answer from A. So it's just going to be 2. Right? Cosecant is the reciprocal of sine. Neat. Saving work. Being lazy. Being lazy while not losing quality. That's the real thing to get excited for. All right, let's do another one. Part C, tangent of pi over 4. So for tangent of pi over 4, well, SOHCAHTOA. TOA means tangent is opposite over adjacent. So you find pi over 4. Any pi over 4 will do. And look at the opposite divided by the adjacent. It's S divided by S. What's S divided by S? Well, anything divided by itself cancels to 1. Tangent of pi over 4 is a real nice one. And let's do one more. Secant of pi over 4. Secant's another reciprocal. It's a reciprocal of cosine. So if cosine, so TOA. If cosine is adjacent over hypotenuse, secant is that reciprocal. Hypotenuse over adjacent. So again, go over to the side, look at pi over 4. Look at the hypotenuse and divide it by the adjacent. And let's write those down. The hypotenuse is the square root of 2 times S. The adjacent is just S. The S's cancel. The secant of pi over 4 is just the square root of 2. And again, we're dealing with trig functions. Sine, cosecant, tangent. These are all talking about ratios. What are the ratios of these sides for these angles? 1/2, 2 over 1, 1 over 1, 1 to 1. They're the same. Square root of 2 over 1, if you want. All right. So that's what we have going here. Good luck. Finally, a little bit of a shorter video. And let me know if you have... Oh, no, we're not done. Never mind. Just kidding. There's another example I wanted to do in this video. Let's do example 5. I tricked you. Example 5. Find x and y. The classic math professor. No, we got 30 more minutes of class. You get out of the seat when I say you can get, well, you can pause. You could actually close the video right now. You don't have to stand for this. All right. So let's look at some problems. All right. Let's look at a triangle over here. Let's say this is pi over 3. This is 2. This is y, and this is x. And there's a couple of ways of doing this. You can do this with special triangles, or you can do this without special triangles. Okay, so one of the ways that you can do this with special triangles, kind of two ways here. Let's do one red way and one blue way. With special triangles, you could say this is a 30, 60, 90 triangle. Right? It's this triangle right here. So whatever this short side is, the hypotenuse is double the short side. So if this is 2, that has to be double that. That's going to say that x is equal to 4 because the hypotenuse is double the short side in a 30, 60, 90 triangle. And then you can do the same logic for the other side, right? Look at the short side. Look at the long side. The long side is the square root of 3 times the short side. So y is the square root of 3 times 2, or 2 square root of 3 by the same reason. So that's one method. The other method is using more traditional trig. I want to figure out what y is. We can find a trig function that relates two things that we know and one thing that we don't. So what trig function relates the adjacent side with the opposite side? SOHCAHTOA. Tangent. Tangent of pi over 3 is y over 2. So if I want to solve for y, just multiply both sides by 2. Y is going to be 2 times the tangent of pi over 3. And again, we can look at our special triangle. What's the tangent of pi over 3? This divided by that. Tangent of pi over 3 is the square root of 3. Okay? And one of the advantages to doing it this way is this works even if it's not a special triangle. So this first method is only for special triangles. The second method is all triangles. And we need to figure out what x is too, right? So we do the same thing, do this again, but with x. Whoa. I can't uncircle that now. All right, so we need to relate these three things. How do we relate these three things? It's the adjacent and the hypotenuse. That's going to be cosine. Cosine of x. Oops, cosine of pi over 3 is 2 divided by x, and solve for x. You know, this one's a little trickier to solve. Multiply x by both sides, get rid of it from the denominator. And that leaves you with x times the cosine of pi over 3. You could also have cross multiplied. Equals 2. And then divide both sides by the cosine. Get 2 divided by the cosine of pi over 3. And again, you can either use a calculator or your special triangles. And you're going to get that the cosine of pi over 3 is 1/2. You're going to get the x equals 4. So obviously, if you can't use the special triangles, it's going to be longer. But if you can use the special triangles, it'll be a little shorter. All right. And let's do one more problem. And then we'll actually be done with this video. It's not going to be short after all. Maybe I didn't fool you though, because you looked under and you saw how long it was going to be before it started. All right, last triangle. Let's say this is 50 degrees. And this is 3, this is y, and this is x. Well, this isn't a special triangle. So we have to use the blue way. Blue way was all triangles. Red way was special triangles, but this isn't a special triangle. This is not a 30, 60, 90. It's not a 45, 45, 90. We got to do the blue way. So solve for x. We need to relate the adjacent side with the hypotenuse. Toa. Cosine of 50 degrees is the adjacent divided by the hypotenuse. Follow the same steps we did before to get x equals 3 divided by the cosine of 50 degrees, and then use a calculator to approximate. All right, so I'm going to go over here. 3 divided by the cosine of 50 degrees. Remember, we have to use Google or your handheld calculator if we want degrees. 3 divided by the cosine of 50 degrees is going to be about 4.6672. That's going to be our x value. And we do the same thing for y. We need to relate these three things: the opposite and the adjacent of an angle. That's going to be tangent. So tangent of 50 degrees is the opposite over the adjacent. Multiply both sides by 3, and you're going to get y is equal to 3 times the tangent of 50 degrees. And again, we'll approximate it to get a value for y. 3 times the tangent of 50 degrees. It's going to be about 3.5753. As a little side note, we'll get into this more later. This has to be 40 degrees up here because the triangle angles have to add up to 180 degrees. The smallest side should always be opposite the smallest angle. So if that's 3.58 and this is 4.67, we should make sure that the smallest side is opposite the smallest angle. That's true. The biggest side should always be opposite the biggest angle. And that's true as well. So it's a good thing to kind of check out when you're doing these. Make sure that your numbers are at least kind of relatively right. All right, that's the end of this video. No lying. This is a long section. Sorry. This is going to be a long class. Wonderful things to say at the end of the video. Good luck, though, and let me know if you have questions. I'm here to help. Don't be shy.